Welcome to the Introduction to Machine Learning module. In this session, we will explore the foundational concepts of machine learning, a transformative field that is driving innovation across industries. This module will cover the basics of machine learning, its applications in areas such as healthcare, finance, and retail, and introduce key concepts that are essential for understanding how machine learning works. Let's dive in and begin our journey into this exciting and dynamic field. Machine learning enables computers to learn from data, uncover patterns, and make predictions or decisions without being explicitly programmed. It involves three key elements: data, which is the raw input collected from various sources; algorithms, which are the step-by-step methods for analyzing this data; and models, which are the trained systems that make predictions based on patterns found in the data. Machine learning powers applications in healthcare, such as diagnosing diseases, in finance for fraud detection, and in retail for personalized recommendations. Its impact is vast and continually growing. There are three primary types of machine learning. Supervised learning uses labeled data, where each input has a corresponding output label. This is commonly applied in regression tasks, predicting continuous values, and classification tasks, categorizing data. Unsupervised learning identifies hidden structures in labeled data, such as clusters or patterns, and is used in tasks like customer segmentation or dimensionality reduction. Finally, reinforcement learning involves trial and error interactions with an environment. The model learns by maximizing rewards or minimizing penalties, often applied in robotics and game AI. To succeed in machine learning, it's essential to understand several key concepts. Features are the measurable input variables, such as the size of a house in a housing dataset. Labels are the target outcomes or predictions, like house prices. Training involves teaching a model using labeled data to find relationships between features and labels. Testing evaluates how well the model generalizes to unseen data. Validation fine-tunes the model to optimize its performance, helping it generalize better to new datasets. Python is the most popular programming language for machine learning, thanks to its simplicity and powerful libraries. NumPy provides efficient numerical computations. Pandas is perfect for data manipulation. Matplotlib helps with data visualization, and Scikit-learn offers a wide range of machine learning tools. With these libraries, you can pre-process data, train models, and analyze results effectively. Together, they form the core of most machine learning workflows.